This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. A blower door does not make a building airtight. It reveals whether the people building that house preserved one continuous air boundary, while dozens of separate tasks were being completed. That distinction is the heart of this subject. The fan may expose a leak, but the leak usually began earlier, when a joint was left open, or a trade passed something through the envelope, without resealing the opening. By test day, the real question is not whether the fan works. The question is whether the coordination worked. I picture the enclosure as a 6-sided box. It has 4 sides, a top, and a bottom. Then I picture every plumber, electrician, heating and cooling installer, sprinkler installer, and low-voltage technician arriving with a reason to cut through that box. Those penetrations are necessary. Leaving the box open around them is not. The useful memory connection is this: find the boundary, follow every hole, and seal before concealment. That short sequence captures the general B responsibility better than memorizing a random collection of caulk locations. Uncontrolled air does not care which subcontractor created the opening. It follows the pressure difference through the easiest available path. One unfinished gap at a pipe, box, chase, plate joint, window perimeter, or recessed fixture may connect conditioned space directly to an attic, garage, crawl space, or the outdoors. Many small openings can add up to a meaningful enclosure leak. The first supervisory decision is identifying where the boundary actually runs. The building envelope consists of the components that enclose conditioned space and separate it from unconditioned space or the outdoor environment. On a straightforward house, that may include exterior walls, the ceiling under a ventilated attic, and the floor above a crawl space. A wall separating living space from a garage can also be part of that boundary. On a more complicated project, the line may turn through roof assemblies, floors, cantilevers, shafts, or demising construction. I do not assume that the boundary follows the easiest path for a crew. I follow the approved project documents and the applicable energy compliance information. The air barrier and the insulation work together, but they are not the same thing. Insulation resists heat flow. The air barrier limits uncontrolled air movement. Insulation placed into a cavity does not automatically close a gap around a pipe or connect an air barrier to a plate. A cavity can look full and still leak. That is why a visual insulation check alone does not settle the air leakage question. I need continuity. The air barrier must connect across assembly joints and around every necessary opening. A tight envelope also does not mean that ventilation can be ignored. Leakage through random cracks is uncontrolled. Mechanical ventilation is a separate, deliberate system. The contractor coordinates both requirements without treating accidental leakage as a substitute for planned ventilation. This is a testable concept based on the published Contractor State License Board study guide, because insulation and weatherproofing involve more than choosing insulation. They also involve coordinating the assemblies and trades that preserve the enclosure. California energy requirements call for potential leakage sources at joints, penetrations, and other envelope openings to be caulked, gasketed, weather stripped, or otherwise sealed. The exact suitable material depends on the assembly, the opening, the approved details, and any fire or listing requirements. The supervisory principle remains constant. The finished seal has to restore the boundary. I put a sealing checklist on screen because the locations are easier to inspect as a connected group. At the bottom of an exterior wall, the plate to floor joint needs attention. At the top, the wall air barrier must connect to the top plate. Under quality insulation installation verification, the exterior wall air barrier is sealed to the top plate and bottom plate in each stud bay. Electrical boxes that penetrate that barrier also need to be sealed. Doors and windows create perimeter joints. Cantilevered floors create assembly transitions. Pipes, ducts, fire sprinkler lines, whole house fans, chases, wiring, and electrical knockouts create trade penetrations. Each location is a reminder that the envelope is a continuous system, even though separate crews build it. Imagine a contractor who carefully verifies the bottom plate seal before rough plumbing. The plumber later drills through the top plate for vent piping into a ventilated attic. The pipe is smaller than the drilled hole, so an open ring remains around it. Nothing about the original bottom plate work closes that new path. The practical response is to identify and seal the penetration with a method appropriate for that location before insulation and drywall hide it. If the opening also falls under fire blocking or another rated assembly requirement, the selected material and installation must satisfy those conditions too. Air sealing does not erase other code responsibilities. This is where sequencing earns its keep. I would rather conduct a deliberate envelope walk after rough trade penetrations and before insulation or drywall than discover inaccessible leakage after finishes are complete. That walk should follow the actual conditioned space boundary, not simply the room sequence. Recessed luminaires deserve separate attention because a fixture penetrating an insulated ceiling becomes part of the envelope detail. The applicable California requirements call for those luminaires to be listed for zero clearance insulation contact and certified airtight. The reported leakage limit is less than 2.0 cubic feet per minute at 75 pascals. A standard housing does not become a certified airtight insulation contact fixture merely because someone applies caulk at the visible trim. The required listing and airtight certification belong to the luminaire construction. Material approval should therefore happen before installation, not during a desperate inspection correction. The central cause and effect is simple. A penetration interrupts continuity. A compatible, complete seal restores continuity. Concealment removes access. That is why timing matters as much as the sealant itself. A blower door test gives an objective measurement of the completed enclosure leakage. A calibrated fan is temporarily mounted in an exterior doorway. Exterior windows and doors are closed, and specified mechanical openings are prepared according to the testing protocol. The fan then pressurizes or depressurizes the enclosure to a target pressure difference of 50 pascals. That pressure difference makes air movement through leaks easier to detect and quantify. During depressurization, air outside the enclosure moves inward through available paths. A person may feel concentrated air movement near a plate joint, window edge, electrical opening, or another missed penetration. The test gathers the combined effect of leakage across the enclosure, rather than judging one crack in isolation. The fan reading is not a contest over how much air the fan can move. The equipment is used to determine how much airflow is required to maintain the standard pressure difference. That relationship allows the rater to report a standardized enclosure leakage result. I also keep envelope leakage separate from duct leakage. The blower door measurement addresses the boundary around conditioned space. A duct leakage test isolates and pressurizes the heating and cooling duct system. Both involve air pressure, but they evaluate different systems and report different information. That distinction matters during troubleshooting. A high enclosure leakage result sends attention toward the building boundary. A duct leakage problem sends attention toward the duct network and its connections. Confusing the two can send the repair crew into the wrong part of the project. The general B boundary is coordination and interpretation, not equipment calibration, pressure correction calculations, or certified test execution. Those technical testing procedures belong to the qualified rater. The standard enclosure result is commonly expressed as air changes per hour at 50 pascals. On written reports, that may appear as the letters ACH followed by 50. It describes how many times an amount of air equal to the enclosure volume would move through the measured leakage paths in 1 hour while the building is held at the test pressure. A lower result means the measured envelope is tighter. A higher result means more leakage under the same standardized test condition. This is not the natural hourly ventilation rate of the occupied house on an ordinary day. The 50 Pascal test pressure is the reference condition used for the diagnostic measurement. Two California thresholds need careful wording because neither should be turned into a universal rule. Under the single-family performance approach, an energy credit may be taken when a home energy rating system rater verifies an envelope leakage rate below 5 air changes per hour at 50 pascals. That is a verified performance credit threshold, and it does not mean every California building has a universal maximum of 5 under every compliance path. A different rule applies when performance compliance modeling uses an infiltration leakage rate below 2 air changes per hour at 50 pascals. In that situation, actual dwelling enclosure leakage measurement is required. That is a measurement trigger tied to the modeled rate, not permission to assume a very tight value without testing. I remember the distinction this way. Below 5 can support the identified performance credit when verified. Modeling below 2 triggers actual measurement. The project documents and compliance path still control the job. I do not need to perform enclosure volume and fan airflow calculations for this general B lesson. I do need to read the reported metric correctly, understand that lower means tighter, recognize which project assumption requires verification, and coordinate corrective work when the result does not support the compliance documentation. The independent certified home energy rating system rater performs the Title 24 diagnostic compliance test. The General B contractor prepares the building and the workflow for that test. Site readiness begins long before the appointment. I would confirm the intended envelope boundary, communicate air sealing responsibilities to affected trades, review products that penetrate the boundary, and establish hold points before concealment. After rough installations, I would inspect plate joints, chases, boxes, piping, duct penetrations, openings around windows and doors, and other transitions shown by the project. The rater controls the testing protocol and certification. The contractor controls whether the work is complete, accessible, and ready to be evaluated. Those roles should support each other without being blurred. Suppose a project produces a higher leakage result than its verified target. The useful response is not to ask the rater to reinterpret an unfinished envelope. I would first confirm that the test configuration and project documentation are being handled by the rater, then use the diagnostic information to inspect the defined boundary. The repair search should be systematic. Start with the largest likely connections to unconditioned space. Check newly created trade penetrations, open chases, attic and crawl space transitions, plate joints, electrical boxes, door and window perimeters, and fixtures that interrupt insulated ceilings. Complete suitable repairs while access remains, then coordinate any required retest. This approach reflects the central lesson. The rater measures the result. The contractor manages the conditions that produce the result. Documentation also helps. Air sealing details can disappear behind insulation, wallboard, cabinets, and finishes. Inspection records, photographs, trade sign-offs, product information, and a documented pre-close walkthrough can make corrective work easier and clarify what was verified before concealment. The required project process controls which records must be retained, but casual memory is a poor substitute for an organized close-in inspection. Spray polyurethane foam can serve as insulation and air sealing material in an appropriate assembly, but its installation introduces hazards that must not be treated like ordinary dust. The chemical components can expose workers to isocyanates, which can irritate the respiratory system and can cause sensitization. A sensitized worker may react to later exposure. The fact that the finished foam becomes solid does not make the spraying process harmless. When employees are required to use respirators, California occupational safety rules require the employer to establish and implement a written respiratory protection program with procedures specific to the worksite. That means respirator use is not reduced to handing out masks at the door. The program governs matters such as medical evaluation, fit, selection, training, use, and program administration as applicable to the exposure. A simple filtering face piece chosen for nuisance dust is not automatically suitable for spray polyurethane foam chemicals. Respiratory protection has to come from the formal hazard assessment and program, not improvisation by an individual worker. The foam installation process also generates heat as the material reacts and cures. Product limits, lift thickness, ventilation, ignition control, restricted access, and re-entry conditions must be handled through the applicable safety information and work plan. I would not invent one universal waiting period for every product and condition. For General B supervision, the practical duties are coordination duties. Confirm that the responsible employer has the required program. Keep unprotected workers and occupants out of the controlled area. Address ignition sources through the approved safety plan. Coordinate access with the installer and applicable safety information. Do not allow schedule pressure to turn a chemical application into an uncontrolled shared workspace. A good air seal never excuses an unsafe installation. Envelope performance and worker protection are separate requirements, and the contractor has to coordinate both. The field review for this topic comes back to one continuous idea. First, find the boundary around conditioned space. Then follow every assembly joint and every trade penetration that crosses it. Verify suitable sealing before insulation, drywall, and finishes remove access. Confirm that recessed luminaires penetrating insulated ceilings carry the required insulation contact, listing, and airtight certification. When the blower door test is performed, remember what it measures. The enclosure is brought to a 50 pascal pressure difference, and leakage is reported as air changes per hour at that pressure. Lower means tighter under the test condition. Envelope leakage is not duct leakage. Keep the California thresholds in their proper lanes. A verified result below 5 air changes per hour at 50 pascals can support the identified single family performance credit. Modeling below 2 requires actual enclosure leakage measurement. Neither statement should be stretched into a universal rule for every project. Finally, keep the roles clear. The Certified Independent Home Energy Rating System Rater performs and certifies the compliance test. The General B contractor coordinates the trades, prepares the site, corrects envelope defects, and protects the sequence before work is concealed. I made an audio practice quiz specifically for this episode, so you can check whether these distinctions are staying with you. It is audio-based. The questions are read aloud, and you answer by tapping, which is useful when you're parked between jobs, taking a break, or studying on the go. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. If you have a question about blower door testing, air sealing, or any distinction I covered, comment below. I read those questions and they helped me understand where another explanation would be useful. Subscribe so I can help you stay on track through every episode until you get your license. I am rooting for you, and I will meet you in the next lesson.